Hi, I am Vidya. I am going to take the topic of computer vision. My subject code is 2280 506. The subject name is Image and Video Analytics. Now we are going to see what is computer vision. Computer vision is nothing but a branch of artificial intelligence that enables computers to see, understand, and interpret images and videos like humans. Finally, our machine think like a human whenever it captures the video and images. So these are the real time example and capture the image through the camera. So after capture the images, enhances that corresponding images and recognize that particular image and decide what is that image. So it takes the decision. So, totally, the computer vision making the machines see, understand, and think like humans. What is an image? An image is a visual representation of an object or scene. In computer vision, an image is stored as a matrix of pixels. So, this is the digital image. That particular image is going to be divided into the number of pixels. So, in this picture, only the particular pixel is going to be zoomed. So, through this iPhone cameras, we take the capture from the real world example. So the key point, this is the matrix of pixels. So like this way only our image is going to be divided into the number of pixels. Every digital image is a grid of numbers, each representing pixel intensity. So the pixel intensity is always representing like this from 0 to 255. 0 represents the black, 128 gray, and 255 is white. See, the key points of this image is made up of tiny elements called pixels. So all the images is a collection of pixels. Each pixels has an intensity value or color values. Means that grayscale values are RGB colors. Millions of pixels are arranged together form a complete image. Computer vision algorithm process these pixels values to understand and interpret the image. Our computer vision algorithms process these pixels and to produce the images. Real world applications may so camera and medical imaging. So medical imaging we are going to take the X-ray, MRI and CT scan and satellite images, land and weather. So through the satellite we are going to take the picture through the satellite, like land and weather, etc. So there were surveillance systems. So in surveillance systems in public sectors, we used all the surveillance systems. So face recognitions, our computer, our machine is going to take the photos. The next one is types of image representation. How we are going to classify the image representation. The digital images can be represented in different forms of based on the pixel values they contain. The images can be represented in different forms. How it is represented in different forms. So these are the four types: binary image representation, grayscale image representation, color representation, and multi hyper spectral representation. In binary representation contains only two values, black and white. So 0 represents the black and 1 represents the white. So this is the simplest form of image representation. For the binary image representation, we have to take the real-time example is OCR, signatures and barcode scanning. Then grayscale, here the pixel values is represented from 0 to 225, contains the shades of gray. So it contains the shades of gray and each pixels has an intensity value from 0 to 25, and real time example is medical imaging. So we use nowadays medical from the beginning onwards medical imaging, CCTV, and these are the two real time example for the grayscale image representation. And color image representation, Each pixel has three values, red, green, and blue, represents full color images. Real time example is photos and videos through the cameras. Multi hyperspectral means we have the multiple brands, infrared, thermal, UV, and others. So captures the image information in many spectral brands through this brands. Then useful for detailed analysis. So whenever we are going for the detailed analysis, we use this multi or hyperspectral image representation. Real time example is agriculture, defense, and environment through the satellite. Different types of image representation are used in computer vision based on the application need. So, based on the application need, we use these types of image representation. The next one is mathematical representation. How we are going to represent mathematically our images. So the digital image can be represented mathematically using rows and columns. So we usually represented our image as rows and columns in the form of matrix. X-axis represents the columns and y-axis represents the rows. Each cell represented I comma j represents the pixel. So every pixel represents the rows and columns. So finally, the second image is if 2 comma 3 is equal to 145. X-axis represents the column and y-axis represents the rows. So we have to take x-axis from 2 and y-axis from 3. Finally, 2 comma 3 will get 145. From the real world scene through the cameras, we have to capture the real world scenes, and it is going to be converted into the digital images. So mathematical representation helps the computers process, analyze, and understand. So these three process is undertaken by the computers using this mathematical representations. Finally, the images efficiently. The next one is resolution and image quality. What is meant by resolution? Resolution refers to the total number of pixels in the image. So, how many images we have, in that each and every image has resolution. So, resolution means the number of pixels. So, total number of pixels in the particular image. More pixels create the sharper, clearer, and more detailed images, because more pixels have more resolution. So whenever the resolution is going to be increased, the picture quality is also increased. So this is the pictorial representation. So this is the low quality and standard quality and good quality. So in this images our resolution is going to be high, and comparatively these two, this picture is very good quality, and comparatively these two, the last image is going to be excellent quality, because the resolution is more high. The resolution means more pixels, which results in better detail, clarity, and image quality. So these are the VGA and HD and UHD. These are the resolution of the images. The next one is the image analysis pipeline. So these are the image analysis pipeline. How the image is analyzed. Analyze, for this we have the pipelines. First, through the cameras we have to capture the image. So the image is captured using the camera. Here the raw data only collected. After capture the image, then the second process is pre-process. Pre-process means remove the noise and improve the contrast and resize the or normalize the particular object or image. Then the next third process is segment. Segment means isolate. Isolate the particular image. Separate the objects from the location or background. So region of interest extraction. So it is going to be extract from the particular object from the background. Detect. The next one is detect the image or find objects. Locate the objects in the image. So the particular image is going to be detect or locate. So draw the bounding boxes for the particular image. Classify. The next process or pipeline is classify the recognized object. Once the object is recognized or detected, so identify the object type, whether it is a car, bus, or person, or whatever it may be, the classify the particular image, then decide. Finally, take action from the computer machine. So the make intelligent decision. So trigger action, break or alert or whatever it may be. So this is intelligent action is done by the machine. So real time example for this image analysis is camera sensors are self-driving cars, it is there, right? So the self-driving car has the camera sensor captured the road scene, so the image is enhanced. Here the image is enhanced for the road scene. Okay, then next one is objects are segmented from the road scene. The particular how many cars or vehicles are going, the particular objects are segmented. Means it is going to be locate for the particular image or object. The next one is objects are detected. What is the object? The particular object is going to be detected. The objects are classified. Here the boxes are drawn for the particular object. Once it is going to be detected, the objects are classified: cars, bus, person. So it is going to be classified separately for the car and person or bus, like that. Then finally decision is made and action is taken. Okay, this is the image analysis pipeline. The next one is key analysis task in computer vision. So these are the key analysis. The first one is acquisition, segmentation, detection, classification, recognition, and decision. Before the slide, what we have discussed, the same thing here also. So this is individually, I'm going to be example in this pictures. So, see, real time example, CCTV camera capturing the traffic on the road. So, this is the CCTV camera. It has captured the image or car from the road. Then segmentation. So, this is the original image. The segmented images separating the car from the background in autonomous driving. Right. The next one is detection. So, detection is detecting the vehicles and pedestrians in smart traffic systems. So only detect the car, bus, person, like that. Then classify the particular object. So based on the label or category, it is going to be classified. Okay. The next one is recognize. Recognize means identify the objects, face or patterns using the learned information. So already model is trained for the mission. So from the trained model, our mission is going to be identify the objects. Then finally decision action, vehicle stops or stop signal, like that our mission is going to be take a decision. Then next one is processing versus analysis. Image processing is input the image, enhance the quality and remove the noise and apply the filters. So these are the process behind the image. So first capture the image, then enhance the quality and remove the noise and apply the filters. So this is the noisy image and process the image. Then image analysis means input. Input is knowledge. In image processing, input is image. Here the input is knowledge. Extract the meaning, detect the objects and make decisions. Real time example is detecting objects in a street scene. So here the image, all the images are available. Our machine is going to be take the decision based on its knowledge. So it is going to be captured the car, bus or person or whatever it may be, then detect the objects, then make the decision. So output is vehicles, peoples, objects are detected. So image processing improves the image analysis extract the information and make the intelligent decision. Then finally, these are the real-time example picture representation of the image processing, face unlock, self-driving cars and medical diagnosis, industrial inspection. Thank you.